Okay, so yesterday it sounds like it was pretty chaotic. So hopefully your day went as smooth as possible yesterday. So couple things. First, to address anybody wanting to do the test corrections, I will give you until Monday to do that because of all the chaoticness of yesterday and me not being here. Thank you. So if you still want to or need to retake the test, you have until Monday. You could even stay after school on Monday if you need to stay after. And then just give the test to whoever's in homework help that day. They'll get it to me. I'll change your grade. So that's that part. Then it sounds like most of my classes, you guys included, actually had a substitute yesterday, but some classes did not. So what I'm asking for you to do is this assignment that I gave you. Can you please put your name on it and bring it up here? Okay. You weren't here. Let me make a list of who wasn't here. Oh, okay. I hope everything's okay. So who else was not here? Literally everybody else is here? Oh, Madison, you were not. Okay. Okay, so just the two of you weren't here? I knew that. Okay, any more? 3 of you not here. That was it. That will be confirmed. Actually, I have a list right here of who wasn't here. Alex isn't here right now either. That's what. Okay. Yeah, that's what it says. Okay, perfect. Okay. So Nick, I just, if you could bring up the paper that you did yesterday with the sub, that would be great. So that was yesterday's. Now, Tuesday, when I was here, your homework was pages 3 and 4. Can you take those out, please? Yes. Oh, what the heck? Hey, Dakota, don't keep my pass. I spent a long time making it. Fancy, right? Thanks. All right, pages 3 and 4. Coming around to check those. That was assigned Tuesday, technically due yesterday, but I wasn't. Okay. Real good. Not today. I'm too stressed to do that today. Okay. Nick, I just need to see yours still. Zach, did you have yours? Okay, you're the row I often skip, so I didn't remember if I went that way. Three. 4, awesome, thanks. Dakota, did I didn't see yours right? Okay.
After I close my.
Okay, so like I said, we're doing pages 3 and 4 was homework. Let's go through these. Pretty simple here. Number 1, in what type of climate is the rate of chemical weathering the greatest? Just a fun fact you got to memorize. What is it? 3. Yeah, warm and moist for chemical. How about which climate does physical weathering, especially through frost action, easily occur? 4, moist and cold. Now, keep in mind for these, they can use any word that means cold or hot. So hot can be replaced with warm, things like that. High temperatures mean warm. For moist, make sure you know that that means wet. How about this? Do you guys know the opposite of a moist climate? What that vocab word is that means the opposite of moist climate? So you would think it means dry. And honestly, dry is not wrong, and you're welcome to use the word dry, but do you know the vocab word that the Regents will use? No, it means it. You're not wrong, but that's not the one I'm looking for. Arid. Do you guys know the word arid? Okay, if you don't, I need you to learn it now. Arid means dry. A desert is arid. So keep that in mind because they will use that word. They love to throw that word out there, and it turns out some people don't know it. So make sure you know it. I just need to see your homework for the other day, 3 and 4. You found yours? 3 and 4. I forgot you guys had so long to do it in class. That's like everybody did it. I see that, Courtney. All right. Yeah, everybody did their work. Every single person who was here did it. That's awesome. All right, so the geological cross section, which rock layer is, again, here's that phrase I talked about at the end of class, least resistant. Does least resistant mean it's getting eroded or not getting eroded? Least resistant means it did not get, no, it didn't. No, it doesn't. Ignore TJ, he's wrong. Least resistant means it's not resisting them at all, not putting up a fight. So it's getting weathered the most. Which one of these that are in the answers 1, 2, 3, or 4 got weathered the most? 2. See how 2 is worn down the most? What you might not have realized is these had all gone up at they were all that size to begin with. And the one that got worn down the most was layer 2, which, just let me remind you, I would not be surprised if instead of giving you the diagrams, they gave you the names here. So you would still see that it was that layer there, layer 2, or layer with the dashes. And then where you figure out the names is right here on the reference table. Are you raising your hand? Yeah, what's up? Did I skip number 3? Yeah. Okay, I'll go back to number 3 in a second. Sorry. So as long as I'm here, let's keep going with number 4. Now I'm confused. Oh, okay. Yeah, I did totally skip number 3. I see why. Anyway, so what I was saying is I would not be surprised if they gave names of these rock layers instead of pictures. So layer 2 was that layer with dashes. So you come here to your rock chart. It could be any of these. So you look through for the dashes and you see that that's shale. Let me just point out the slight difference with siltstone. That's the one they're going to try and mess with you with. See how that one is dashes and dots mixed together? So just always look closely and really match them up. So this one is shale. All right, back to number 3. Chemical weathering will occur most rapidly when the rocks are exposed to. What do we need in order to rust something or to hydrate something? You need oxygen and water. And then I look at those answers and I'm like, what the heck? None of those words say oxygen and water. But there's fancy names there. We've learned these. What's the hydrosphere? So this is saying water. Anytime you see hydrosphere, you should be thinking, oh, that's just water. What's lithosphere? That's the rocks. That's the layer. That's what the plates are made out of. So did rocks need to be exposed to water and rocks to weather and erode? Nope, it's not water and rocks. We need water and air. Here's another one with water. What's atmosphere mean? That's the air layer. Water and air. By the way, we have not talked about these 2 yet. They're in our next chapter, thermosphere and mesosphere. They are layers of the atmosphere. So that's just both air. And that's the only one that you didn't know. Why will a rock weather more rapidly if it's broken up into smaller pieces? 4, there's more surface area exposed. The more surface area, the more spots for weathering to happen on. Now, how many of you looked at this graph and got a little intimidated before you even kind of looked at it? Yeah, this is one of the messiest graphs I've ever looked at. But once you just take it bit by bit, you should have seen that the x-axis was just temperature. Y-axis was just the mean annual precipitation, so just the amount of rain or snow. And then each spot on the graph just had a label that went with it. So let's kind of go through this. Which climate conditions would produce very slight weathering? Look right there, very slight weathering. So really all this was doing is saying we needed a temperature and a rain to hit somewhere in this bubble here. So which one did you get to line up there? All right, 2, 15 and 25. Yep, right there, very slight weathering. How come there's no frost actions with places with a mean annual temperature greater than 13 degrees Celsius? And you might have needed to know something about Celsius. The answer number 1, very little freezing takes place. Absolutely. Guys, what temperature does water freeze at in Celsius? Okay, so here's where water would freeze. So if your average temperature is way over here, means it doesn't freeze very often. It's not saying it'll never freeze, but it very rarely would freeze there. So we wouldn't have frost action. By the way, if you didn't know that about water, next chapter, we're going to introduce you to this reference table, which is basically just 3 thermometers. And they do tell you what temperature water freezes, what temperature water boils. So you don't have to memorize that information if you did not know that. Finally, what type, there's no particular type of weathering or frost action giving for the temperature and precipitation values located and represented by the letter X here. And they want to know why. To realize that, you had to read this right here, this arrow pointing to this dotted line, and it says approximate limit of possible temperature precipitation conditions on Earth. What this is saying is anywhere above this line, that temperature and that amount of precipitation could never happen. So there is no place on Earth where it's 0 degrees and gets 175 millimeters of rain. Just doesn't ever happen. So these conditions probably do not occur on Earth. That's answer 4. And then finally, -5 and 60 puts you around here. And they picked that box or that spot on purpose because there was no label in the area. Like this one has slight frost action. They picked this one because that area was left blank. Hopefully you followed the arrow and you read moderate frost action. So answer number 1. Any questions on that stuff? All right. So again, if you have not already, can you please turn in this paper from yesterday with your name on it? There's a pile up there. And we're going to turn to page 7. We are moving on from just plain old weathering. Now we're going to be talking about a little bit of more weathering, erosion, and deposition. Thank you. So this is page 7. Before we even get started with the new stuff, quick reminder of the vocab word weathering. And yes, I do want you to put this in your packet right at the top. So I'm not sure if you can tell by how many times I've already talked about this, but you absolutely need to know what the vocab word weathering means. Can you describe weathering in a couple words? No. Okay, if you can't, flip back to page 1 where we took notes on this and see what the word weathering means. Yeah, sorry, McKenna, there's a packet of them for you. Is that what you're going to ask?
Yeah.
right there under that green marker. Yeah. The breaking down of rocks into smaller pieces. Breaking of rocks into breaking of rocks into smaller particles. Oh, quick vocab check here. What are smaller particles called in earth science? Sediments. Please make sure that you know that smaller particles, that's the same thing as saying sediments. As in sediments that make sedimentary rocks. So see how these chapters are tied together? How weathering and erosion gets tied right back to rocks and minerals super easily. Also is going to get tied into the weather chapter we're going to do shortly. The Regents loves when chapters kind of intermingle, and they will absolutely mix them up for you as they're asking questions. So always make sure you remember the stuff we learned in the past and use it and apply it to stuff we're doing now. All right, so on that note, let's go right ahead and get back into the PowerPoint. So, of course. So what's erosion then? So if weathering breaks the rocks, what does erosion do to those newly broken pieces of sediments? And charades for the win. Sean just went like this. Takes them away. Could not have put it better. Just make sure you can turn. Oh, that was a shock. Make sure you can always turn your charades into words for the Regents. So right there at the top of page 7, what is erosion? It is the movement of weathered material from one place to another. Movement of weathered material from one place to another. What's another word for movement? How else might they phrase it? Huh? Traveled. Okay, traveled is another word for movement. What's another word that they might use instead of movement or traveled? Transported. That's actually the word the Regents uses most often. Transported. So if materials are transported, it's just a fancy way of saying moved. Blown from or moved from, any of those, just any phrase that means moved, just make sure you realize they're talking about erosion. Speaking of, what are some things in nature that can move sediments from one place to another? Give me one. Animals, humans and animals absolutely can be moving them. Let's talk more in the earth science realm though. Water, what do you mean by water? What are you talking about? Streams and rivers. There's also another type of water that can move some sediments. I actually gave an example of it the other day. Glaciers, yes, absolutely. Frozen waters is another one. That's not what I was getting at, but oceans and ocean waves and currents. So water obviously plays a huge role in erosion. What's another thing? So we've got glaciers, streams and rivers, and waves so far. What's something else that can move? What? Wind. So wind can move sediments. You guys, I think, was it last year you learned a lot about the Dust Bowl? Was that last year? 8th grade was the Dust Bowl for you guys? Okay. The Dust Bowl was the best example of wind erosion that you have ever learned about. There's one more thing that can move sediments. Earthquakes can. Yeah, that's not where I'm going with it though. Earthquakes will maybe cause them to break loose, but in the end, it's this thing I'm looking for that will gravity. Oh, is that not what you said?
No, I think gravity, I didn't know.
Yeah, it's literally gravity is what I'm talking about. So instead of just calling these things that can move sediments, they are referred to as agents of erosion. So that's the next bullet you have there, agents of erosion. There are 5 of them. Wind, running water, which is talking about the streams, rivers, creeks. So wind, running water, waves, glaciers, and this one goes gravity, then glaciers, sorry. So get all 5 of those, doesn't matter the order. So again, we've got wind, running water, waves, glaciers, and gravity. I went in the wrong order again, but get those 5. It doesn't matter what order. So they do separate all the water ones because they each erode in their own manner. So waves behave different than creeks and rivers. Ice, so glaciers behave way differently than the other 2. So they are considered their own agent, running water, waves, and glaciers. What? And gravity. Gravity obviously does its own thing, so does wind. All right. So again, just so we have it, we already know weathering breaks the rocks, erosion moves the rocks. What does deposition do? Huh? I just couldn't hear you, that's all. Okay. We got broken, moving. What can we say deposition does? Drops them off, okay. So puts them someplace else, leaves them be. So deposition officially is defined as the process by which sediments are released, settled from, or are dropped off by the agent of erosion. Process by which sediments are released, settled from, or are dropped off by the agent of erosion. I don't need this big fancy definition. Holton's answer of dropping them off was perfect. So we do like to keep it simple in your brains. Weathering breaks, erosion moves, deposition drops off. If you can at least get those couple of words for each definition, you're perfect. Weathering breaks, erosion moves, deposition drops off. And you cannot interchange them in your head. You cannot say weathering when you're talking about stuff moving. You cannot say erosion when you're talking about stuff being broken. You have to keep them straight in your head. Weathering breaks, erosion moves, deposition drops off. By the way, how can wind drop off sediments? What's the wind got to do? No, how does it drop them off? It stops being moving. Sorry, not movie. That was dumb of me. It stops being windy. That's where I was going with it. That's what you said. In the Dust Bowl, when did it stop blowing the dust? When it stopped being windy. When does a river drop off sediments? When it empties into a lake. What's the river do when it empties into a lake? What actually happens to the river? What happens to you when you're going down a water slide and you hit the pool on the bottom? It is cold, no doubt, but you suddenly stop, or at least slow down and then stop. So rivers have to stop flowing to drop off sediments. So we'll go through every single agent of erosion one day at a time. At the bottom, so below that hand, there's a phrase there and it says blank is the driving force of all agents of erosion. It makes rivers flow. It makes glaciers slide, and it makes sand fall from the wind. What am I talking about that makes glaciers slide, rivers flow, and wind fall, or sand fall from the wind? Gravity. You do need to understand that even though gravity is its own form of erosion, it is also what we call the driving force behind everything else. Without gravity, there would be no erosion. Right, we would probably exist in some other weird environment.
We would just be floating around.
Yeah, we'd be floating around, or I mean, like on the moon where they kind of do that hopping thing. So we wouldn't quite be floating. There's enough. Well, I don't know. Maybe there wouldn't if there was no, because the moon has some gravity. So yeah, we'd probably be floating. Yeah, it definitely would be a different world. That's for sure. Yeah, we wouldn't be here. Yeah, we wouldn't be here. You're right, Sean and Madison. Yeah. Yeah, I hate these types of questions when you guys like make up stuff that isn't true and then I have to stop and think about it. I call them what if questions. And what if questions, I always say we talk about what if questions at special class I hold on Fridays at 5 o'clock every week. So be here on Friday at 5 o'clock if you want to talk about what if questions. Dude, PM. By the way, in case anybody's getting any ideas, I'm being sarcastic. I do not actually have a class at 5 o'clock on Fridays, but I always say that so that people are like, oh, no, I'm not coming. And then I blame them, not me. But this year, some of you guys seem actually like really intrigued, and I would be afraid somebody would show up and then I would have to like be here. And I don't want to be here on Friday at 5 o'clock either. Okay, moving on. Sorry. So we're going to go ahead and start talking about these 5 agents of erosion. So if you flip over in your packet to page 8, on page 8, I had intended for you to hold your paper, or to turn your paper sideways. If this bothers you, the same thing can be achieved going across. So whatever makes you more happy, but again, this is what I meant. And that's why we're going to be starting with glaciers. So I know it's at the bottom if you hold your paper the right way, but if you turn it this way, glaciers is at the top. So how we're going to work these notes, there is a spot for a sketch. I am not a teacher who makes you draw things just for the sake of drawing them. Because I hate drawing and I'm bad at it. But some of you like it. So more power to you. You're always welcome to draw pictures next to words and stuff. But I don't make you. Until today, the reason I'm making you is because pictures will actually help in this situation. So the top box is for a sketch. The bottom box is for big ideas. If you accidentally switch them, just change the labels then for me, would you? So we're going to first basically, have any of you ever seen a glacier? Oh, I lied. We're not doing glaciers first. Gravity is much more entertaining today. So I'm ready for some entertainment. So we're doing gravity first. So we're doing the one at the top of the page. Any idea how gravity moves sediments? Down. Literally, gravity moves sediments down. I am going to take you on a little virtual picture tour of what gravity erosion looks like, because other than saying, okay, here's the pen up here and it moves down, we can't see any of gravity erosion in my classroom. We have to go somewhere, and it's not really outside today. So let me pull it up here where I want to go with this. Actually, let's watch videos on it first, because these videos, they're quite impressive. So I like the other video first. No, thank you.
Portland, Oregon, February 1996. A mountain begins to move, and for a contractor and his son,
But I will
there's
remind
only
you
one
that this
option.
was, I was 13.
Get out of the way fast.
So, it's not quite what you're used to.
my God!
They had just gone head-to-head with one of nature's most powerful and destructive forces, a landslide. The surface of our planet is constantly reshaping itself, and landslides are a major reason. They strike wherever the soil is loosened by rain or tugged by gravity. It can be a rockfall or a raging river of mud. But wherever the ground fails, it can result in massive destruction. On average, landslides kill more than 8,000 people every year around the world. They can crash down without warning and travel for several miles. In the U.S., landslides occur in all 50 states, but some places are more dangerous than others. Landslides usually follow other natural disasters like volcanic eruptions, earthquakes, wildfires, storms, and floods. Steep slopes are obvious places for landslides, as are areas that have been hit by landslides before. But they also frequently occur where people have radically altered the landscape. Hills stripped of vegetation, slopes modified for roads and buildings. And as our cities and towns expand further, landslides become more frequent and more destructive. In 1998, disaster struck the Southern California suburb of Laguna Niguel. Few realized that the man-made hill beneath them could fail. The ground, eroded by heavy rains, began to give way, and the houses came crashing down. 7 were seriously damaged, and 5 of them tumbled down the cliff face. Though the ground cracked and the earth plummeted, no one was injured. The residents of Laguna Niguel were lucky. They still had their town. The following year in Venezuela, torrential rains triggered widespread landslides across a 25-mile-wide strip of coastline in the state of Vargas. Communities were buried under waves of mud and debris. It's estimated that 30,000 people were killed, around 10% of the area's population. Accurate death tolls were difficult to establish because so many people vanished under the mud or were swept out to sea. Though the catastrophe was on a massive scale, it is by no means unique. Such disasters have happened before and will happen again. As long as the earth continues to move, people will live with the threat of landslides.
So that's some pretty dramatic.
We're taking 50% off your first box of fresh food.
Stop playing. That was some pretty dramatic landslides and gravity erosion. Here is just another
in eastern Tennessee, a dramatic rock slide that will give any driver the chills. It began as a trickle, then it all came crashing down yesterday on U.S. Highway 64. Yikes, it was the second rock slide that morning. Crews had to break up the car-sized rocks to clear the road. Good morning, everybody. How about that? Man, look at that.
So the road wasn't blocked off at the time, yeah,
Was
even
not.
though there had been a previous.
Where was the camera?
No.
That's
Good
like,
question.
We are
who took
everywhere.
that-
We are everywhere.
Great question.
I'm just going to sit here until these rocks
Look at
come
that.
down.
That is amazing.
Well, there had
Stunning.
been a couple of previous ones. I guess they were watching.
You guys can see whether Andy Roseman taking.
I'm late, honey, I'm late.
Well, you know
It was
what?
a rock slide.
Oh, yeah. Right.
All right, so those hilarious news reporters, whatever, so weird. I have some more to show you. So we're gonna go back to some pictures. Not all gravity erosion is as dramatic as those ones in the video. Those ones happen real fast, but sometimes they happen much slower. And that first example is going to be this one. Can you guys see these trees? I am sure you have, if you've ever taken a walk in the woods around here, you've probably seen some trees like this. What do you notice is kind of weird here? Their trunks are bent. Why? So this whole weird bendy trunk thing. They are going on a steep hill. What do you guys know about trees and the way they grow?
They have to move it so if they're on.
They like to grow towards the sun, up. And trees will, and plants for that matter, will adjust themselves so that they're growing best. Over here, at my plant wall, I rearrange these plants almost weekly. All I do is turn them. Why do I have to turn my plants?
So it's all surface to the sun.
It's not just so they all get the sun. What do the plants do when they're towards the window? They grow towards the window. So if I didn't turn them pretty much once a week, those plants by the end of the school year when I take them back home would be completely leaning to one side. So by turning the plants, I'm making sure they grow straight. Well, what's happening here that's causing these plants to, or these trees to have curved? The land, yeah, basically. So when this tree that's super curvy was a baby, what was different about the land?
Straight.
It was probably straighter. Yeah, the fact that they curved like this, it means at that point, that part of the trunk used to be standing straight. And this hill has slowly slid down, making it a little steeper. This is called creep. Why do you think it's called creep? Because it's creepy? Because it looks weird? It's not that. Because it's something that's slow and subtle until voila, one day you notice it. If someone's creeping around, what are some of the things they're doing? They're going slow, quiet. They're hoping to go unnoticed. So again, here's some fence poles that are doing the same thing. I'm not sure if you can see that these are the fence posts. They're completely leaning down the hill. Do you think that's how the farmer put them there? No, those were upright. And over time, the hill slid down the hill and took the fence posts with it. Here's another example. These are drainage tiles under a bridge. Again, they did not put them there like this. They were nice and flat, but over time, gravity has pulled the bricks down and they started to buckle like that. Here's some more trees. Here's some other ones. This is more like what we just watched in the videos. These are huge hunks of the land falling, typically all at once. With this word, this is called the debris flow. What do you think of when you hear flow? Rivers flow. So this would be when the ground is going to flow. Here is, this one's an avalanche, I believe. It's hard to tell from the picture, but it's a pile of snow that all of a sudden broke loose and fell down the cliff. Could be a landslide too. This is the aftermath of a landslide. What do you notice about that house? It's buried. Wasn't built in the ground. These rocks were piled on top of it afterwards. What do you notice about the size of the pieces surrounding the house? And so I see big rocks, but what else do you see? I see soil and dirt. So whatever was on the hill fell down the hill and buried the house. Here is what's called a lahar. This is a mixture of ashes, like the ashes from a fireplace, but in this case, ashes from a volcano that mixed with water and made this really thick mud-like substance that comes off of volcanoes. This is another mudslide that has literally covered the house up until the eaves. So luckily these kids were able to get out. Debris fall. What's different with a fall than a flow? It just goes clump. It just falls down the hill. Plunk, falls down. So this is a case where like the sides of a cliff might break off like this. So here would again be the aftermath of that. Again, what do you notice about the size of the rocks? The big and little. That's going to be really important. I always love this animation, but we've got a mountain and we've got a massive rock fall and this teeny little tiny town. But one thing I want to point out is look at this at the bottom of the cliff. What do you notice? Yeah, there's like a pile of dirt there. That's the debris after it falls off the cliff. And what's gonna happen with these rocks? They're gonna pile up there on top of this slope, and there will become a small slope at the bottom of these mountains. Here is again a very similar picture to the video we watched, and again you can see there. Here's the steep slope, and then it kind of piles up at the bottom and creates another little hill. These are called talus slopes. So that's actually a thing you got to know about, are these little slopes at the bottom of a cliff. So that is the end of the pictures. We'll take notes on this tomorrow. No homework tonight.